University of South Florida. I will be giving a short presentation on my Programming C final project, which utilizes user-defined functions. The objective for us as electrical engineering students was for us to think outside the box and try to use everything that we learned in Programming C so far, as well as getting us used to or just making us remember how to use initial conditions. So we needed to create a script that will find the zero input response of a second order linear time invariant system based on user inputs for the coefficients A1 and A2 and the initial conditions y0 and y prime 0. And luckily for me, I've already taken differential equations, network analysis, and linear controls. So I was pretty comfortable with equations, the initial conditions, and finding the roots. Here is my formula sheets for when finding the roots for distinct roots, right? Having C1 and C2 as the constants. For the repeated roots, having C2 and C1. And for the complex roots, which use the inverse of tangent and also finding C and Z. So my script and everything that is going to be calculated throughout the script are based off these formulas. So one of the main things that my professor wanted to drill in our heads was the importance of algorithms and steps, which is basically what a pseudocode is, and how I will formulate everything that I want to run in the code. So first I'm going to open a new script. And once that script is open, we're going to create 3 user-defined functions that will take 4 different arguments as float variables. So the 3 user-defined functions will be distinct roots, complex roots, and repeating roots, with they're all separating using the underscore. And they will have float variables b and d, which are based off the quadratic formula, and float variables y0 and y0 prime, which are the initial conditions. And then once we're done, we're going to save this as a project x.h file, and the .h stands for a header file. We will use that. So once that is saved, we're going to open up a new script, and we're going to include 3 different header files. The one that we just created, which is project.x.h, stdio.h, which is basically standard input, standard output, and math.h, which holds a majority of the math functions. And using the formulas provided in the formula sheet, we will define all 3 of the user-defined functions that will calculate their own separate variables. So you have distinct roots again, complex roots, and repeating roots. And each function will have their own set of constants, like C1, C2. And here's an example for repeating roots. Lambda, C1, and C2. And these are based off the formula sheet that was provided. And once all 3 of these user-defined functions are well defined and using the formulas, we're ready to start the main function. Once the main function has started, we're going to, 1, prompt the user to enter the coefficients of A1 and A2. Then we want to prompt the user to enter the initial conditions, y0 and y0 prime. From there, I want the code to display the second order linear time invariant system based off the user input for the coefficients and initial conditions. So from there, I want to define in the main function that d equals a1 squared minus 4a2, or I guess a squared minus 4ac, if you're used to that in a quadratic formula. And as well as define root 1 and root 2 based off of the quadratic formula. From there, we will be using conditional statements to call out our functions. So if d is greater than 0, we will call out the distinct roots function. Else if d is less than 0, we'll call out the complex roots. And then a else function to say if it's neither one of those, then it's going to be repeating roots. Then I want the code to display the second order linear time invariant system based on the user inputs for the coefficients and initial conditions. Display roots 1 and 2. Display if the system is distinct, complex, or has repeating roots. And then basically end program. So here starts the actual script. So this is going to be that header file that I talked about for the distinct roots, complex roots, and repeating roots, right? Save that. You may want to save both C scripts in the same folder, however you may please. But here is the header file, project x.h. So like I mentioned earlier, we want to include 3 different header files. Pound, include studio, standard input output math.h, and the header file that we created, project x.h. And from there, we're going to define all 3 user-defined functions. So you have distinct roots, lambda 1, lambda 2, C1, C2. All of these were based off the formula sheet that I provided. The second will be complex roots. The formula for alpha, beta, z, c, theta. The atan2 is basically that 2 is for 2 arguments, which is z and y0, and the repeating roots. So starting the main function, we're going to create some float variables, a1, a2, y0, and y0 prime. The user will be prompted to enter the initial conditions y0 and y0 prime and the coefficients a1 and a2. And then the program will display the LTI equation with the initial conditions. Next are some more float variables, d, root 1, and root 2, which d is basically a part of the quadratic equation, and root 1 and root 2 will be, I guess, the results of the quadratic equation, the actual roots. And then from there, we're going to move on to some conditional statements. So if d is greater than 0, it will display the roots are root 1, root 2. Else if d equals to 0, I'm going to say it as repeated roots and it will display root 1, root 2. Else if d is not greater than 0 and d does not equal 0, then it will be complex roots, and that will be shown. So for our second set of conditional statements, we're going to actually be calling out those user-defined functions. So if d is greater than 0, we're going to call out distinct roots, right? Else if d is less than 0, going to call out complex roots. And then else, using the if, else if, and now else, then it will be repeating roots. We'll call out that function. And that's pretty much the end of the code. So here's the result. User is prompted to type in A1, A2, both initial conditions. Then from there, the program displays the LTI system based on the user inputs, and displays a result. And for this one, is distinct roots. The roots are unique. They are not the same. It is not complex with roots in negative 5.5 and 4.5. So that's pretty much the end of my final project for EEL 2161, Programming C. Thank you for your time and patience.